Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the June 2023 Pure Mathematics P4 paper from the International A-Level Edexcel exam. This question here is about what are called differential equations. So here we have the temperature in theta degrees Celsius of a car engine t minutes after the engine is turned off is modeled by the differential equation d theta dt equals negative k times, in brackets, theta minus 15 squared, where k is a constant. Given that the temperature of the car engine is 85 degrees Celsius at the instant when the engine is turned off, so that's like t minutes after the engine turns off, so that's when t equals 0. So from this we can deduce when t equals 0, theta is equal to 85. And it's 40 degrees Celsius exactly 10 minutes after the engine is turned off. So from this we can deduce when t is equal to 10, theta is equal to 40. We have to solve the differential equation to show that according to the model, theta is equal to a times t plus b divided by c times t plus d, where a, b, c, and d are integers to be found. So in the end, these must be integers, otherwise we've done something wrong. All right, so we start off with this differential equation, and we have to end up with something that looks like this. Okay, so how do we solve a differential equation? So first of all, what is a differential equation? That's the first question we need to ask ourselves. Now, a differential equation is an equation that has a rate of change in it. Okay, for example, d theta dt, dy dx, d theta dy, whatever it is, you have a rate of change in it. Okay, so d theta dt is the rate of change of the temperature with respect to time. Okay, and to solve a differential equation, you have to write what's on the top here. You have to write what's on the top here. Okay, so I have to write the theta as some function of what's underneath. So theta in terms of t. So if you solve an equation involving dy dx, in the end you have to end up with y equals some function of x, and so on. Okay, so we have to in the end have theta as some function of t, as we have here. Theta is equal to some constants times t, basically some function of t. All right, so that's what we need to do. We need to solve this differential equation. That's what it means. We have to do that. And in this case, we're going to have to find out what all these constants are. We have to find out what k is and all that when we are doing this. Now, how do we solve a differential equation? Now you'll find people doing different things. They'll move this here and move this there and move that there and stuff, but you might not understand what they're doing, all right? So what we can do here is, what I want to try to do is to show you some sort of a process which hopefully makes a little bit of sense so you understand what we're doing. Okay, so the first step is for me to show you exactly what, what happens when we solve any equation. Like if I want to solve an equation saying, 2x plus 3 is equal to 7, for example. We do something to one side, what we do to the other side. So you don't like say the 3 flies over the equal sign and becomes negative. No, think about it as we take away 3 from this side. So therefore we have to take away 3 from the other side of the equation, and you end up with 2x equals 4, and then we want to get rid of this 2, so we have to do the opposite or the inverse operation. So we divide by 2, but we have to also divide the other side by 2, so we end up with x equals 2. Right? Or even when we are, for example, doing something like finding the sine of, we know the sine of x equals a half. We want to find what x is. What we do is we try to get rid of the sine x, so we take the inverse sine of this side. Okay. And therefore we take the inverse sine of the other side as well. What we do to one side, we do to the other. So the inverse sine of the sine of x, they cancel out, leaving you with just x. Like we know that if you have something like this or something like this, okay, that just gives you what's in the bracket. They cancel each other out. So x equals inverse sine of half, which then gives you 30 degrees, and whatever other angles share the same sine ratio. So basically the point is what you do to one side, you do to the other. Okay, and that's true for solving any type of equation. All right, so that's true for solving a differential equation. So I want to get theta. So I want to do something. What I'm going to do to this side and that side is the same thing. So I'm going to integrate this side with respect to t. So I have d theta dt integrated with respect to t. And I'm going to do the same thing on the other side. I'm going to integrate minus k times theta minus 15 squared with respect to t as well. What I do to one side, I do to the other. Okay, so I just integrated this with respect to t and this also with respect to t. Okay, now what's going to happen here is that you can say these cancel out. So we've got the integral of this. Basically what's here is there's a 1, which is not written, d theta, equals, I can take the constant outside, minus k times the integral of theta minus 15 squared dt. Now the problem here is that this doesn't fit with this because this is integrating something with respect to the variable t, but we have the variable theta here. And here we have the variable theta. So the theta side has to have all the variables that has theta in it, and the t side has to have all the variables with t in it. Now, because we want now to make this, to put this on this side of the equation, we can do that. Okay, we can divide both sides by theta minus 15 squared. Okay, so I can divide this side by that and I'll end up with 1 over theta minus 15 squared d theta equals minus k. That cancels from this side, so now you're left with just 1 here and you've got dt. Okay, so now we're almost there. We have to think about how we can try to integrate something like this. How do we integrate something like this? Well, we can integrate it if we rewrite it in this form as theta minus 15 squared d theta, 15 to the power of minus 2, sorry, d theta equals minus k times the integral of 1 with respect to t. Okay, so now this can be integrated by reversing the chain rule, because you can, add 1 to the power, divide by the new power, and then multiply, then divide by the differential of what's inside the function. That you have outside the function a constant, which is 1. Okay, and if you differentiate what's inside the function, you also get a constant. So therefore, you can reverse the chain rule. All right, so now what I like to do here, to save myself from putting plus c and then putting the values in, what I'm going to do is I'm going to take the pair of values that we found here. Okay, so I'm going to take this pair of values here. All right, and bring them down. I'm going to use them down here now. We just get rid of these arrows. Okay, I know when t is 0, theta is 85. So what I'm trying to do now is I'm trying to find the value of k. So I'm going to integrate this with respect to theta and this side with respect to t, and use these values in my limits. I don't have to put plus c then. Okay, I can just find, it will give me the constant of integration straight away. I'll be able to find what k is straight away. So I know this side is where you have theta. You know when theta is 85, that's when t is 0. And when theta is 40, that's when t is 10. Okay, so you have here something which you can deal with now. Okay, so now what we're going to do is we're going to integrate. Let's integrate this. So if you integrate this side, you're going to have your square bracket because we're going to put limits in now. If you integrate this, you're going to add 1 to the power. So you have theta minus 15 to the power of negative 1 divided by negative 1 multiplied by 1. Doesn't make a difference there. The differential was inside the function. And you're going to have your limits 85 and 40. And on this side, you're going to have minus k times, and this is going to be t. And you're going to have 0 and 10. No need to put the plus c now. Now, let me just simplify this side a little bit. So you have, that's going to be minus 1 over theta minus 15. You're going to have 85 and 40 equals minus k times, I'll just leave this like this for now so I can then put them in together. So this, what I'll do is I will take this to the other page. Okay. And continue. Okay, so we've got this now. This is how far we got. Now what I'm going to do is to make life a bit easier here. There's a minus here. And so like if I multiplied the top and bottom by minus 1, this will become basically 1 over 15 minus theta. Okay, 15 minus theta. So I multiply if I take this as a minus 1 over theta minus 15 multiplied by minus 1, that will be 1 over 15 minus theta. That makes life a bit easier, I think, when we are substituting values in. Minus k, and you got t and 0 and 10. Now we can start putting the values in. So you have 1 over 15 minus 85 minus 1 over 15 minus 40 equals minus k times 0 minus 10. Okay, so now this gives you negative 1 over 70, and that's minus negative 1 over, that's 25, is equal to minus k times minus 10, which is 10k. So what does this give you? This gives you basically 1 over 25 minus 1 over 70 equals 10k. So let's work out what that is. 1 over 25 minus 1 over 70. That gives you 9 over 350. So we can say 10k is equal to 9 over 350. Therefore, k is equal to 9 over 3,500. Okay, so now we can, I'm going to take this. Okay, I'll copy this, because that's what we got when we integrated. Now we found the value of k. We can work on using this. All right, so I'm going to go back to this here. I'm going to get rid of the limits, and I'm going to put in the value of k as it is. So k is equal to 9 over 3,500. So minus 9 over 3,500, because it said minus k. And now I can say, look, I'm trying to find theta in terms of t. Right? I know I can use either of these pairs. I could use 40 and 10. I could use 85 and 0. I think 85 and 0 is probably easier. So I know that when the time is 0, the temperature is 85. Now this will help me to find theta in terms of t without having to use the plus c, without having to use the constant of integration. I can just find what theta is in terms of t. It will basically find the constant of integration for me automatically. That's how I like to deal with this type of question. Okay, so you have 1 over 15 minus theta. So what we're going to do is we're going to now substitute these values in. So we have 1 over, there's no integration needed to do. We've already integrated. That's done. I'm putting this in here first, minus, and I'll put this in here. So I have 1 over 15 minus 85 equals minus 9 over 3,500 times, and you got t minus 0, which is t. Okay, so this is 1 over 15 minus theta minus, and this is going to be minus 1 over 70 equals minus 9t over 3,500. Okay, so you end up here with 1 over 15 minus theta plus 1 over 70 equals minus 9t over 3,500. Now remember, we want it to look like, in the end, something like this. Okay, so always keep that in your mind. That's how it has to end up looking. It's end up looking something like this. Okay, keep that in your mind. All right, I've already got it written there anyway. Okay, so now what should we do? Let's isolate this term. Let's subtract 1 over 70 from both sides. So you have 1 over 15 minus theta equals minus 9t over 3,500 minus 1 over 70. Now, how do I make this how do I combine these together? 5 times 7 is 30. So if I multiply this by 50, then I multiply that by 50, they'll have the same denominator. That will be 3,500. That will also be 3,500. So we have 1 over 15 minus theta equals minus 9t minus 50 over 3,500. Okay, now what I can do here is I can multiply both sides by minus 1. Okay, so in this case, this is going to become 1 over theta minus 15 equals, and this is going to become 9t minus plus 50 over 3,500. That brings the theta to be positive. Now, I know that you have a fraction on this side equals a fraction on that side. So I can basically flip the fractions. Okay, I can write this as theta minus 15 over 1 equals 3,500 over 9t plus 50. So now we're almost there. This is like theta minus 15 equals 3,500 over 9t plus 50. So we can now say theta equals 3,500 over 9t plus 50 plus 15. Now we can combine these into one fraction as this is. We can write these with the same denominator, which is 9t plus 50. This one is as okay as it is. And this is going to be 9t plus 50. And there will be 15 times 9t plus 50. So that gives you theta equals, you have one common denominator, which is 9t plus 50. 9t plus 50. And on top you have 3,500 plus 9 times 15. That's 9t plus 45. That's going to be 135t plus 15 times 50. That's 15 times 5. I think that's 75. So 750. Okay. So we can combine those two together. Let's just make sure in case I made some silly mistake there. Let's do 3,000. Let's do 15 times 9. 135. And you got 15 times 50. Sorry, 15 times 50. 750. Add that to 3,500. That gives you 4,250. So you have theta equals 4,250, or we can say 135t, because we want it in this form here. So let me bring that down. I want the t's first. Let's just write it in exactly the same form that they want. So we have theta is equal to, that's going to be 4,000. It's going to be 135t plus 135t plus 4,250 divided by 9t plus 50. So that's what we had to show. So we found this in the right form. They are integers, as we said they should be, and everything is in the right place. Worked out fine. So that's good. That's the answer to part A. Part B says hence, means using your answer, of course. Find, according to the model, the time taken for the temperature of the car to reach 20 degrees Celsius, giving your answer to the nearest minute. So basically we want to find it what t is, and theta is equal to 20. So we replace the theta with 20, and we have 135t plus 4,250 over 9t plus 50. So we can multiply both sides by 9t plus 50. So we have 20 times 9t plus 50 equals 135t plus 4,250. So that's 20 times 90, which is 180 times t, plus 20 times 50, which is going to be, that's going to be 1,000, right? 2 times 50 is 100 plus a 0, yes. And that's going to be equal to 135t plus 4,250. So you have 180t minus 135t equals 4,250 minus 1,000. So 180 minus 35, I think that's going to be 45, isn't it? That's 45t equals, that's going to be 3,250. So t is going to be 3,250 divided by 45. Okay, so we have 3,250 divided by 45, which gives us 650 over 9, 72.2 recurring, 72.222. So we can say t is equal to the nearest minute, 72 minutes. So there's the answer to part B. That's just using the model that we found to substitute the values in and find the value of t when theta is equal to 20. All right, so that completes this question, question number 6 from the June 2023 paper from Edexcel International A-Level. That's other questions from this paper can be found in the playlist that will appear in the top right corner of the screen at the end of this video. Other questions from the topic of differential equations in the playlist at the bottom over here. You can subscribe to my channel by clicking on this link, and over here you can watch a video telling you how to find my index of different topics for different types of courses like IGCSE, Cambridge, Edexcel, AS, A2, whatever. Thank you for watching, and see you soon.